geobyte.
Let us take the another important problem. Okay, look at the screen. It is asking like this. A sample of 0.1 gram of water at 100 degrees centigrade and normal pressure 1.013 into 10 power 5 Newton per meter square requires 54 calories of heat energy to convert to steam at 100 degrees centigrade. If the volume of the steam produced is 167.1 cc, that is cubic centimeters, the change in internal energy of the sample is the similar problem, almost a similar problem we have done. Do you remember? Yes. Anyhow, it is given that mass of the water equal to zero point 0.1 gram. 1 gram. Zero point 0.1 gram of water is equal to zero point 0.1 cubic centimeters. Okay. At 100 degrees centigrade and pressure given, that is standard pressure 1.013 into 10 power 5 Newton per meter square requires 54 calories. The heat Q equal to 54 calories. To convert it in joules, 1 calorie equal to 4.18 joules. 54 into 4.18 joules. It is 225.72 joules. That is the approximate value. Then the steam volume, that means initial volume of the water is zero point 0.1 cc. Final volume of the water is becoming steam 167.1 cc. cc. Okay. Now remember 1 cc equal to 10 power minus 6 meter cube. That means to convert from centimeter cube to meter cube, it should be multiplied with 10 power minus 6. Therefore, it is equal to zero point 0.1 into 10 power minus 6 meter cube. The other one also 167.1 into 10 power minus 6 meter cube. The change in internal energy of the sample is the change in internal energy du equal to how much? The change in internal energy du or delta U is how much? For that, we need to decide the work first. Work equal to PdV. PdV. P given 1.013 into 10 power 5. The dV means V2 minus V1. V2 is 167.1 minus zero point 0.1. It is 167 cc. It is equal to 167 into 10 power minus 6 meter cube. So 167 into 10 power minus 6 meter cube. Meter cube. You simplify this value for getting around 16.91 joules. That is the work. Okay. Then del Q equal to del W plus du. From this change in energy du equal to del Q minus del W. Look at the del Q. Del Q is 225.72. 225.72 minus del W 16.91. You simplify it approximately for getting 208.8 joules. That is the change in energy. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. This is the most expected problem. I am writing 5-star problem. 5-star problem means this kind of problem can be repeated. Okay. Similarly, let us take the another important problem. Asking like this. Two rods A and B of different materials are welded together as shown in figure. Look at the two materials. This is the material 1, material 2. These two materials are joined by welding process. Their thermal conductivities are K1 and K2. K1 is the thermal conductivity for the material A. K2 is thermal conductivity for the material B. The thermal conductivity of the composite rod. You are asked to decide what is the equivalent thermal conductivity of the composite rod. For that, capital H must be equal to H1 plus H2. The heat transfer for the equivalent system is K equivalent into A, 2A in fact, into 2A into, let me write it clearly, 2A into T1 minus T2 divided by length that is given as D equal to K1 into A into T1 minus T2 by D plus K2 into A into T1 minus T2 divided by D. Now here 2A, I mean A T1 minus T2, A T1 minus T2, A T1 minus T2, A T1 minus T2 cancel. K equal, of course D is also cancelled. K equivalent into 2 equal to K1 plus K2. Therefore, equivalent thermal conductivity equal to K1 plus K2 divided by 2. That is the answer. Look at the option A. Option A itself is absolutely correct. Understood clearly? Yes. Similarly, look at the another important problem. Asking like this. A spherical black body with a radius 12 centimeters radiates 450 watts power at 500 Kelvin. Here initial radius R1 equal to 12 centimeters. Initial power P1 equal to 450 watts at T1 equal to 500 Kelvin. If the radius were halved, that means R2 equal to R1 by 2. R1 is given 12. 12 by 2, 6 centimeters. And temperature is doubled. T2 equal to 2 times the T1. T1 is given 500, that is 1000 Kelvin. The power radiated in watts would be the power radiated, according to Stephen's law, Stephens, according to Stephen's law, the radiated power P equal to sigma into A into T power 4. Here A equal to what? Pi r square for a spherical body. Then P equal to sigma into pi into r square into T power 4. From this I can write that power is proportional to r square into T power 4 because both sigma and pi, both this is sigma and pi remains constant. Since power by r square into T power 4 is proportional to 1, I can say that power by r square into T power 4 remains constant. So let me take another slide. Power by r square T power 4 remains constant means P1 by R1 square into T1 power 4 equal to P2 by R2 square into T2 power 4. You are asked to decide what the second body radiated power P2. From this P2 equal to P1 into R2 by R1 square into T2 by T1 power 4. So P1, look at the P1 value given 450 watts into R2. Look at the R2. R2 equal to 6. R1 equal to 12. 6 by 12. R2 equal to 6 by 12 square into T2. Look at the T2. T2 equal to 1000. T1 equal to 500. Right? 1000 by 500 power 4 is equal to 450 into 1 by 2 square into 2 power 4. It is 450 into 1 by 4 into 2 power 16. Right? 2 power 4, 16. 4 times. 450 into 4. 4 times. 98, 90, 900, 1800. 1800 watts. That is the answer. P2 equal to 1800 watts. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. Two identical bodies are made of a material for which the heat capacities increases with temperature. That means the specific heat or heat capacity is not constant for the material. Heat capacity is increasing along with the increase in temperature. Okay. One of these at 100 degrees centigrade. Among the two, one is available at 100 degrees centigrade, while the other one is at 0 degrees centigrade. Okay. If the two bodies are brought into contact, then assuming no heat loss, the final common temperature is, okay, it is like this. Since the heat capacity is changing or heat capacity is increasing with temperature corresponding to T1 equal to 0 degree centigrade, heat capacity let it be, right, S1 equal to some 1. It is just assumption only. Since heat capacity is increasing with the temperature corresponding to 100 degree centigrade, definitely the heat capacity is more than 1. That is just 2. Let it be 2. It is also assumption. Okay. Then the final common temperature. The final common temperature I can write S1 T1 plus S2 T2 divided by S1 plus S2. S1 is 1 into T1 is 0 plus S2 is 2 into 100 divided by 1 plus 2. It is equal to 200 by 3, around 66.6. Right? That is the temperature which is in degrees centigrade approximately. That means temperature is greater than 50 degrees. Okay? Right? For getting the approximate value, we have assumed. Those values may not be exactly correct. Anyhow, the answer is more than 50 degrees centigrade. Understood clearly? Yes.
Geobyte.